Welcome back to my channel Success Engineering Official. So today we are going to continue with this chapter 2, and we will start from refrigerant. So last tutorials I explained you this up to this latent heat. So today we'll continue with this refrigerant, and we will study about different types of refrigerants and its classification. So before start this video, I would like to request you guys once again. If you are still not subscribed my channel, so please do subscribing and hit the bell icon as well, so that whenever I upload the video, you will get the notification of that video. Also, please like and share my video. So let us start now. As you can see here, this is refrigerant. So okay, so refrigerant. What is refrigerant? Refrigerant is nothing but it is the heat carrying medium. Okay, it will carry the heat during the cycle which reject heat at condenser and extract heat at evaporator. Okay, in the vapor refrigeration cycle, this AC will work at a vapor refrigeration cycle. Okay, so this refrigerant will fill inside the pipe. Okay, and it will carry the heat during the cycle which reject the heat at condenser. At condenser, it will reject the heat and it will extract the heat at evaporator. Okay. In the condenser, once the refrigerant will reach at condenser, the high pressure, high temperature refrigerant will discharge by compressor and it will send to the condenser. So at condenser, it will reject the heat because at condenser, this condenser fan will start run and it will extract the air outside here and throw on the condenser coil. So during this process, this high temperature refrigerant will reject the heat and it will change its phase from liquid to gas to liquid. Okay, and then it will pass through this expansion valve and it will enter in the evaporator. So in the evaporator, it will extract the heat. It will gain the heat again from the this room air will throw on the evaporator by fan. So due to this, it will reject the heat. It will extract the heat from the air, and the air it will transfer the heat, and air will get cool, and refrigerant will get heat hot. So during this process, this liquid refrigerant again converted into the gas refrigerant. Okay, and then it will go to this compressor again. So this is how on this is what we called refrigerant. Okay, so this is the work and this is the process of refrigerant. Now the classification of refrigerant. So there are three types of refrigerant. Three classification of refrigerant is divided into three types. So CFC is nothing but the chlorofluorocarbon contain ozone depletion layer. The example of CFC refrigerant is R12 and R502, etc. So C is chloro and F is the fluoro and C is the chlorocarbon. So C is nothing but the chlorine atom and then fluorine atom and one is the carbon atom. So this is in ozone depletion layer. Next one is HCFC is nothing but the hydrochlorofluorocarbon. It contains less chlorine than CFC, approximate 8 to 10% less chlorine than CFC refrigerant. Okay, this is the family of refrigerant. And the example of HCFC is nothing but the R22. R22 is the chlorodifluoromethane. Okay, and R408A, R409, etc. And third one is HFC is nothing but the hydrofluorocarbon, no chlorine content. In this, there is no chlorine. So the example of HFC refrigerant is R134A, R404, R40410, etc. So here this is a zero depletion layer, so there is no chlorine. That means it will not affect to this environment. So mostly we are using nowadays HFC refrigerant. R134A is also known as tetrafluoroethane from the family of HFC refrigerant. Okay, and now we will see the properties. So properties of refrigerants. So first property of R1340 is R134A is boiling point. So it will boil at minus 14.9 degree Fahrenheit to or minus 26.1 degree centigrade. So at this temperature it can boil. So from the room, the return air is coming around. The temperature of return air was around 18 to 24 degree Fahrenheit, 24 degree centigrade. So it can easily boil. Okay, it can boil at minus 14.9 degree Fahrenheit or minus 26.1 degree centigrade. Auto ignition temperature, so 1418 degree Fahrenheit or 770 degree centigrade, it can auto ignite. ODP, ozone depletion layer. So ozone depletion layer is zero for this refrigerant, and it is soluble in water. It can dissolve in water as well, 0.11% by weight at 77 degree Fahrenheit. Critical temperature is 252 Fahrenheit or 122 degree centigrade. The color code of this refrigerant is light blue and global warming potential GWP is 1200. Next one is R410A. It is the binary blend of hydrofluoric carbon or HFC compound, 50% of R32 and 50% of R125. No chlorine content, no ozone depletion potential, and the global warming potential is 1725 for this refrigerant. Next is vapor compression cycle. So vapor compression cycle, it is the closed system in which energy transfer but mass is not transferred from or it is it uses refrigerant as a working substance. So vapor compression cycle, there are four cycle. So you can see this is the compressor, the from compressor, and there are four cycle, which is compressor, condenser, expansion valve, and evaporator. So our AC will work on this cycle. So in detail, I will explain you in the next tutorial. So I hope you guys learn something from this video. So if you learn something from this video, so please do subscribe my channel and hit the bell icon as well. Also, please like and share my video with so don't forget to watch my next tutorials because this is very important topic, vapor compression cycle. So vapor compression cycle, our AC will work on this cycle. So I will explain about the function and function of this component and how the refrigerant will compress inside this cycle. So I hope you guys learn something from this video. So thank you for watching my video. Thank you. Bye bye.